Let's take a look at another functional equation. The question is like find a continuous function f from real number to real number such that f of xy equals x times f of y plus y times f of x. So when you look at this functional equation, it is somehow like the product rule in the calculus, which is like u times v, the whole term takes the derivative, equals u prime v plus uv prime, where if you regard the f to be the derivative. Of course, the solution of this problem has nothing to do with the derivative, so let us just erase that. So now we can see if you divide xy on both sides, we will have f of xy over xy on the left side. And on the right side, we will have x f of x f of y, x times f of y all over xy plus y times f of x all over xy. Then we can just cancel x for the first term and cancel y for the second term on the right side. So the right side will become, this is f of x over x, and then this one will be f of y over y. So now we can see that on both sides, it is somehow like the f with three different arguments and then all over the same argument, so that we can just define another function g of x to be f of x over x. So in this case, the equation will look like g of xy equals g of x plus g of y. It is something like the Cauchy equation, but actually not the same. The Cauchy equation is like f of x plus y equals f of x plus f of y. So it is somehow like the linear relationship. Actually, this is not the same. As we can see on the left side, we have g of xy rather than g of x plus y. But actually, it is a variation of the Cauchy equation or another type. Sometimes we will call it a type 3 Cauchy equation. And actually, if you just remember the solution, it is like g of x will be log of x with base a. A is arbitrary positive value. Actually, we can see how to make some substitution of variable so that we can come up with this solution without memorizing it. As we can see here, we have x times y in the argument, so that we may define another function to be g of x equals h of log of x, natural log of x, or any with any base is fine. So that on the left side we will have h of natural log of xy equals h of natural log of x plus h of natural log of y. So in the left side, natural log of xy will be h of natural log of x plus natural log of y. And on the right side, we have h of natural log of x plus h of natural log of y. So we can see that if we just let log of x to be s, log of x to be s, and log of y to be t, log of y to be t, okay, so we have h of s plus t equals h of s plus h of t, which means that h is actually the Cauchy equation, so that we can come up with that h of s should be c times s. So the linear relationship, actually without the constant term. So h of s equals c times s. So now we can have h of natural log of x equals c times natural log of x. And actually, h of natural log of x is actually g of x, which means that g of x should be c times natural log of x. Actually, we can just put this c to be like 1 over natural log of 1 over natural log of a, and then natural log of x. Here we define that c equals natural log of a. This is constant. This is constant. Actually, a is larger than 0. Yeah. So in this case, we can rewrite it as log of x with base a. Actually, it is quite equivalent, so it doesn't really matter. So in this case, we have, going back to here, we can have f of x equals x times log of x with base a. However, as we can see, the domain should be from all the real number, but log function does not define for the negative value. So actually we may put the absolute value here, and going back we can actually put absolute value maybe here, natural absolute value here, so that all the x can be defined without 0 without 0. So we can see the solution look like this. Of course, another solution will be simply f of x equals 0, because on the left side will be 0, on the right side will also be 0, and this function is continuous. So we should have two set of solution. One is f of x equals x times log of absolute of x with base a, and another one is f of x equals 0. So let's check. This one is already checked, and on the and for the first set, as we can see on the left side, f of xy would be x times y log of xy with the absolute value with base a, and then applying the rule of the logarithm. So we have xy times log of absolute value of x with base a plus log of absolute value of y with base a. So we distribute xy into this expression. We will have, let me see, y times x log of absolute value of x with base a plus x times y log of absolute value of y with base a. And then we can put the parentheses so that we can see clearly it should be y times f of x plus x times f of y, which is the right hand side of the functional equation. Actually, it is arguable that whether x to be 0 is defined for this function, because you may say that x is 0, so that this term is 0, and then this term may be negative infinity when x tends to 0 on the right side. But you may say that actually the log is not defined, so that even it multiplied by a 0, it shouldn't be 0. So it is arguably that whether f of x is defined at x equals 0. But at very least, you can use the L'Hopital rule to show that limits x tend to 0 plus f of x equals limit x tend to 0 minus f of x should be 0. So at least this function is continuous at x equals 0, even though f of 0 is arguably non-defined at x equals 0. So finally, whether you agree this f of x is defined or not, we may say that this 2z is the solution of this functional equation. And this is the end of this video.